Well, hello. My name is David, and today I want to talk a little bit about why and how you need excellence, especially technical excellence, in order to be agile. So I had the idea for this talk just about a year ago, but this topic has been following me around for probably something like 9 or 10 years. So a very long time ago, I gave a talk titled Software Architecture and Scrum. And probably what I told back then was a little bit naive, but not completely wrong. And then after the talk, someone in the audience asked or said, yeah, well, that's very nice, but you can't do this when you have only junior developers. And I was like, yeah. And then, so this question in one form or the other, I have heard it time and again in the last 10 years. Can you do something like Scrum with only junior developers? And we will come back to this question at the very end. For now, maybe a little bit of context for what I will be talking about. So you are in a company, medium-sized company, large company, probably an established company that suddenly decides, or the C-level executives decide, we now want business agility, or we want more business agility. And yeah, basically Wikipedia says business agility is the ability of a business system to respond to change, and by adapting its own initial stable state. So basically the business has recognized that it doesn't respond to change fast enough, and they want to get better. On the other side of the corporate hierarchy, developers just want to do their work without getting interrupted all the time. And so we see movements like, yeah, I mean, extreme programming started like this, and a couple of years ago, software craft, what was back then called software craftsmanship, which is an approach that really concentrates on how to build software right, because we want to do a good job. Yeah, and wherever or however this started, this company now does, well, maybe the thing with the big and the small loop, or the thing with the slightly more complicated board, or if you want a process that is very similar to the old-fashioned process you have now, then you can use the one with the trains. And yeah, so somebody decides we now follow some agile process, and you bring in business consultants, and you rename all the roles, and you provide 2 days of training for everyone. So like these sheep through this disinfectant, everyone goes through 2 days of training. Yeah, and then, congratulations, you're agile. And everything is fine, right? That's how it works. The managers get their bonus, and we're agile now. But in reality, you probably start facing new problems, and you probably start seeing problems that were always there, but nobody recognized them. So both is happening. Problems become more visible, and new problems were created. So in reality, not everything's nice. And yeah, after I gave this talk for the first time, I had an idea to write a book about these things that are not working well, and also give you some ideas what I believe are the root causes and what you could try next to fix them. But I'm not here to only shamelessly plug that book to you. But you will get a discount code at the end. But now I actually want to write about something that is, oh, sorry. I now want to talk about something that is only a very small part of the book, which is technically excellence. But before we come that, again, the only thing that matters, what we're talking about is not how well you follow Scrum or something. What we're talking about is your company wants to become more agile. And that's not something what you do on a team level. That's not some rituals you follow. That's a property of the organizations. But the teams probably have to do something and have to follow some rituals to support that. So, Agile is, among other things, about reducing development risk, especially Agile software development. I mean, that's what we're talking about here. And we do this by delivering a finished product early and often, by making sure we work on stuff that matters, by being able to react in case of an emergency, and by not breaking stuff that already worked. So, and in the rest of the talk, I want to argue that when you get better at technical things, that when you get your technical practices right, then these 4 things will become easier. Talking about not breaking stuff that already worked, yesterday I flew in from Austria via Frankfurt, and the flight from Frankfurt to Heathrow was delayed by almost 30 minutes because of a software update. So the software that assigns the seating in the plane that worked for the last 10 years or so assigned the seating wrongly, and the plane was not trimmed, and everyone had to change places in the plane. It was fun. I could sit on my place and did not have to change with someone else, but yeah. So yeah, we don't want that. We don't want to break things that already worked. Okay, and Agile is also some things that Agile is not. Agile is not necessarily faster. So for every single feature you are doing, you will probably be slower than just hacking it together or working in the old way, because you do a lot more things. You write tests before you even start to implement things. You design a lot more. You think a lot more. You plan more. You have some kind of rework just through iteration. You first build something simple, then you make it a little bit better, then a little bit better. So you probably do more, and maybe some or even most of the features will take longer than if you would not work in an Agile way. But the idea is that Agile should be cheaper in the long run because you reduce the development risk by not working on the wrong things, by making sure stuff doesn't break, and so on. So what I said before. So that's the idea. And also, this is something that is very important and that a lot of companies get wrong. And I found this nice little quote. I hope I translated it correctly from German. If you use Agile methods only to become more efficient, then you basically lose all the advantages and get a lot of disadvantages. So it's not about becoming more efficient. It's about working on the right things and working in a sustainable way. Working today in a way so that even 1 year in the future you can still work in a sustainable way. And also, I mean, I hope I don't have to say that, but Agile is not necessarily equal to Scrum. I still think you can do everything that's in the Scrum guide and not be Agile at all, or Safe or Kanban. And Agile is also probably not what causes your problems. So you have some new problems, but they are probably caused by how you transition towards an Agile way of working, not by Scrum itself or Kanban or whatever you're doing. Another quote from J.B. Reinsberger: Agile is not a thing that's running around and causing you problems. It's a tool that you can use or not use, and the idea is to get more money earlier. So basically to provide something of value earlier so you can get more money earlier. Okay. Let's talk about the 4 points from before. So we want to reduce development risk, and the first thing we do is we deliver something finished and valuable early and really, really often. That means we will have faster time to market. We will get paid earlier, or even if it's some internal software development, so we are developing software for another department, then they will be able to do their work better earlier, and they will save money even if we don't get paid more earlier. And if there is no more budget, we don't have to extend the deadlines. We can just stop and use whatever we have. So in most waterfall projects I was in, that was a very long time ago. I'm glad about that. But in one project, we had a deadline, and on the day before the deadline, the release was delayed for 3 months. And then after 3 months, it was still not finished. So this should theoretically not happen anymore. Yeah, and faster time to market becomes more and more important. As Uwe Friedrichsen said in a talk some time ago, everyone is affected by economic Darwinism. Some traditional companies already feel the pressure, like banks feel the pressure by fintechs, but sooner or later, every traditional company will be affected by this, and the only key thing is to meet the customer's demands earlier and better than the competition. So it doesn't matter how big you are or how much money you have, this will not save you in the long run. All right, we also want to reduce development risk by making sure that we work on stuff that matters. That means we want to get good feedback, and we want to get it often. We want to run many small experiments all the time and not plan big projects and then have a post-mortem afterwards. We want to find and eliminate waste, so we want to stop working on things that don't matter. And that means we must have product development experts. So this is one thing I wrote about in my Agile anti-patterns book, and I called the anti-pattern, I mean, the name is not from me, but I wrote about working in a feature factory where you exactly don't do these things, where you just, whatever the customer wants, you turn that specification into code, like a factory turns raw materials into widgets, and where you don't care about working on the right things, you just care about delivering what was requested. So that's not what you want to do. You really want to make sure that you work on something that is valuable to the customer, not just on what the customer has said they want. We also want to reduce development risk. That was the third point from this slide some time ago, by being able to react in case of an emergency. So we must have some slack in our process. We must work in a sustainable way where when something really important pops up, we can delay something else, or we still have time to do the important thing. We want to learn from every success and failure to be able to react even better in the future. And this means we must manage our knowledge, and automating everything helps with being able to react faster. So if you have automated processes where no human error can happen, then you can react faster because you can trust the process that comes after that, after you reacting to the emergency. And yeah, we also do not want to break stuff that already worked, which means we also have to somehow automate testing user visible behavior, or at least reliably make sure that user visible behavior doesn't change. So there's some techniques for doing that, like behavior-driven development, agile acceptance testing, specification by example. You could say that these are only 3 different names for the same things. I think it's more like 3 different viewpoints on the same thing, or 3 different angles to view on this. And yeah, we need even more automation to make that sure. Or at least we must make sure that deployments work and that rollbacks work, which is easier when they are automated. And we probably also want to do automated problem detection and mitigation, or at least try to move towards that. I have interviewed Peter Ritzler from a small company in Linz some time ago about how they are working in their company. And one thing that impressed me that he said was, we must move away from the idea that we can create bug-free software. And they are, at this time, they were spending a lot of time and resources and person hours into trying to automatically find problems and maybe automatically mitigate that by restarting servers, by killing network connections, and so on. And if this wasn't possible, by automatically notifying people who could solve the problem. So this is something that might be cheaper in a lot of situations, to just find the problem quickly and try to automatically solve it, than to prevent the problem in the first place. There's a theory, or in a discussion with some other people, in a very heated discussion, where we talked about whether it is worth it to work on well-crafted code. I then just wrote down my theory of why well-crafted code will ship faster. So the discussion went like that. I said, okay, there's research from, I think, IBM, that teams that have lower defect potentials are also faster and cheaper, and some people relied, yeah, that research might exist, but all the research we have is crap anyway, and you can't rely on it, and yeah. So I just wrote down my ideas, and here I want to tell them. If you want, I can tweet the blog post afterwards, but it's basically what I'm telling you here. So the theory is that well-crafted code will ship faster. So first of all, why do we want to ship faster? Shipping faster means that we can deliver a finished product early and often, which is how we reduce development risk. And it also helps us getting good feedback earlier, which also helps us to indirectly reduce the risk of working on the wrong things. And this helps us making sure that we work on stuff that matters. So what does it mean to ship things faster? So what we're basically talking about here is lead time and cycle time, and both will influence how expensive your software is and how early you can earn value. So I guess we're at an Agile conference. Everyone knows this term, but just to remember how most people in software development are using them. I just have to switch to. So the lead time would be from idea to until delivering something that is usable. So from the time we know we must do something to the time we've used it, our customers can use it. And usually in software development, or at least in the original Kanban book, they said that cycle time is the time from when the team starts working on it until the team declares it finished. This is not how they use the term cycle time in manufacturing, but all software developers, or all that I know, use it like that. So basically, that's what we're talking about. And so the longer these two times are, the more work in progress you will have in parallel. The longer your customers have to wait for something, some of your features will become obsolete while you are developing them. Like there was some research that Alan Kelly quoted a couple of years ago that requirements change on average at a rate of 2% per month. So if you have a lead time of a year, then probably 25% of your requirements will already be obsolete, or at least not valuable anymore, like how you developed them. So yeah, the longer these times are, the more the harder it will be to work on stuff that matter, and the more time you will waste. And also, especially talking about this cycle time where the team works on a feature, this directly influences the cost of a feature. Like, so with a stable team, the longer you take to implement the feature, the more expensive it gets. That's pretty easy. The only real expense we have in software development, or the only relevant expense we have, is the salaries of the developers, or the not the salaries, but their full cost, their fully loaded cost. So the longer they take, the more expensive it gets. With a team that is not stable, it's a little bit more complicated, but it only gets more expensive. So still, the longer it takes, the more expensive it is. And yeah, I already said that speed and scope, the longer you take until from you've got to deliver something until you deliver it, the higher is the chance that the users don't even need this anymore, or need a small change to it, or that it is not that valuable to them anymore. So yeah, the scope changes and some things become obsolete. And there's also one more thing when we talk about speed, and that is the cost of a feature as a function of when you implement it. So you have somewhere on the y-axis the cost, and x is when. And the same feature, like as a user, I want to have a forget password or a reset. I want to be able to reset my password. Will be really, really cheap when you implement it at the beginning of the project, and then at some point it will become more expensive, and at some point it will become really expensive. So especially, or yeah, for some projects it's like this, where at some point it seems like we cannot get any features out of the door anymore. Oh my God, what happened? 2 years ago, all the features took like 2 days, and now we are working on this simple feature for the second sprint. What happened? And for some other projects, the curve is a little bit better, where it still gets more expensive, but only a little bit. Or so this is twice as good. And this is also something that I wrote a little bit in our book. I called this anti-pattern of the higher line architecture madness, where when you try to start to work in an agile way, one of the things you hear is that you're supposed to do evolutionary architecture now, but nobody really knows how to do it. And you have so many other problems, people problems, process problems. Suddenly working together with other departments doesn't work anymore like before, that you just don't do any architecture at all. And the cool thing is it works for like 2 or 3 years, and then you suddenly face this hockey stick curve where suddenly features are becoming really, really expensive. And here we're finally getting to the point where I say that well-crafted code is cheaper and can be developed faster. Because exactly this hockey stick happens because suddenly the design and the architecture of your code is not suitable anymore for what you want to do. It becomes hard to change. It becomes hard to navigate. Things are more error-prone, like you change something here and something in a completely unrelated part of the software breaks. For every bug you fix, another bug pops up. So this is exactly why, in the long run, well-crafted code will ship faster and thus be cheaper. And by well-crafted code, I mean code of high quality, with a good architecture and design, with very little defects and where it's easy to fix those defects, and with a lot of automation about tasks around the code, like automated tests on different values, automated deployment, and so on. Okay, what does high quality actually mean? I mean, this is something that when you think about is very hard to pinpoint and define, and I won't even give you a definition here because I don't like any of them. But the key is that there's probably something like external quality, something that your users care about, or where your users would say this is good or this is shit. And something like internal quality, which is what your developers and testers care about. And they basically have nothing to do with each other. You can have something that is very well defined and that is a joy to work on, but no user likes it, and vice versa. Like there are some rumors that some parts of the Apple operating systems were in this category and not in this. Not sure if they are true. I mean, it's a very secretive company. So, but what I want to get to here is that external quality probably doesn't have a direct influence on speed and cost. Maybe it allows us to get better feedback, but I'm not even sure about that. So this is something you should probably get right to even get paid or to even convince customers to buy your product, but it will not make you faster or slower to get this right. Or if anything, then it might make you slower because you will invest time in UX design and user research and stuff like that. Internal quality, on the other hand, will have a huge influence on whether your development speed will be fast or slow. And the idea here is that you can only make it worse. So when the internal quality gets worse, when it will be harder to find things, when it will be harder to even know where to fix something or which changes you need to do to completely solve a problem, then you will get slower and slower because you will introduce more defects in the process, you will spend more time fixing those defects, and developers will, in the first place, spend more time even finding out what they have to do to solve a problem. Speaking about defects, it's also quite hard to even pinpoint what a defect is. Like, I mean, there's this definition, like, doesn't do what's in the specification, but what if the specification was crap, and we probably don't even have one. So we can't really use that definition in an Agile project, and I had also a longer discussion with J.B. Reinsberger whether there is a difference between a defect and a mistake, and like both are something where the user is in a situation where the software doesn't do what they expected, but the defect would be that we should have known what to do and just broke it, and the mistake would be nobody had already known what would be the correct behavior. But yeah, not sure if this makes sense, but we talked about it. But the key is defects are ridiculously expensive. So things where your team has agreed that this really is a problem in the software and it came into production and you have to fix it are very, very expensive for your team and also expensive for every one of your users because they can't do their work right now. So there's where I want to get back to this research. I think it was in IBM, and I don't have it in my notes, but it's in the book Code Complete. This research is quoted where it said that teams that have a low defect potential and a high defect removal efficiency had the shortest schedules, the lowest costs, and the best customer satisfaction levels. So really, code with less defects is cheaper and faster. And to achieve that, we probably need a lot of automation. So we want to eliminate human error from every process. Every process that you could automate but don't will cause you problems at some point in the future. At some companies, or at some of my clients, managers started talking about the automation trade-off, like we only automate things if we have to do them more than 4 times per year, because otherwise the automation is more expensive. Yes, you could talk about things like that, but my take on this is just automate that stuff, because when you're talking about that automation trade-off and decide to not automate something because you only do it 4 times a year anyway, then it might not be cheaper to automate it. It might be even more expensive. But if you don't automate it, then you lose a lot of possibilities. Like if you have automated testing and then there are some tests that are not automated, then this creates a lower bound of your lead time. Like every time you have to do this test again, maybe before a deployment, you add this time for manual testing, like a day or so. So you cannot deploy multiple times per day just because you did not automate this one test. So you lose some possibilities that you would have if you had automated everything. And there's also Bernd Greifeneder, the CTO, I think, of Dynatrace, the company that does application performance monitoring. I talked to him about these topics, and he said in their company, they are spending a lot of money, like millions of euros every year to automate things and to make automation better. And he said, that's just my nature. That's my way. I'm an engineer, and that's the way of the engineer. You just solve every problem in a sustainable way. And that means automation for them. OK, so well-crafted code will ship faster and will remove some of the development risk from your project. But you still have to have slack in your process. Like, you still want to be able to respond to emergencies, and that's only possible if you're not completely overworked already. So do not fill your sprints. This is the first thing. Like, keep some time, like 10 or 20% that you would usually use for technical improvement, refactoring. Just ask the team how many user stories will you be able to do, and they say 7, and then you say, OK, let's agree on 5, and the other 2 are for just to have some slack if something bad happens. Also something that at least one team I worked with, I couldn't convince them to do that, but do not start new features near the end of the sprint, where you would know, OK, this will take us at least a week. We have 2 days left. Why do we start this now? Why don't we do something else now and start this at the start of the next sprint? So if you do this, you will always have more work in progress than necessary and finish less than necessary. If you do Kanban, really obey the VIP limits, especially when times get rough, because they are not there for the sunny days. They are there for helping you when times get rough. And create some slack time. So like Google had this 20% time. I think it's not something you're supposed to do anymore, but they had it. And Smarter E-commerce, the company I was talking about before, they have something they call a Freaky Friday, where on a Friday afternoon, one of the developers is the DJ, and he plays music in the company, and everyone else is not supposed to work on anything that's in the current sprint. So they are supposed to do either research or technical improvements or stuff like that. And if something really, really important pops up, then they can do it there. But most of the time, they are not supposed to work on something that's in the current sprint. Which is, and my anti-pattern for this is refactoring backlog, where you don't do this, you don't have enough slack, you don't have enough time to do the things that are important to the team. So the team creates their own backlog, like we would like to do this and this and this and this, and they create the list from this. This is our team backlog, and whenever we have time next, we will fix these things, and this will probably never happen. Yeah, and we have to learn from every success and failure, which means what Joel Spolsky called fix everything twice. So sometimes you have to do the quick fix. You have a production problem. You do a quick and dirty fix, but don't forget to come back and fix it in a sustainable way. So you should fix every defect twice, especially production defects. I heard something at a talk about how NASA went to the moon, where they had a post-mortem after every problem that occurred. Even if they were sure that this was a one-off thing, they still tried to prevent it in the future. So I think we sometimes take this too easy. Yeah, okay, this was an outlier, this was a one-off thing, we don't have to really discuss that, it will not happen again, and we can't do anything against it anyway. And so we just don't have a retrospective about that. No, we should talk about it. And we should institutionalize learning and experimenting. So one former client of me had what they called, the company was called Matema, and they had the Matema Friday, where it was a consulting company, and at one Friday every month, all the consultants were not allowed to work for their clients. They had to come to the headquarters, and they had 1 day of talks, workshops, stuff like that every month. Another thing, again, smarter e-commerce, they have lightning talks. Every day after the daily Scrum, one developer is supposed to hold a 10-minute lightning talk about some new technology or something that they read online or whatever. So every day after the daily Scrum, they have a 10-minute lightning talk, and they have a token where always the next one must hold the talk. Yeah, the thing here is, Christian Gorbach told me, they try to find employees who are willing to do that, who are willing to constantly learn. And everyone says that they are willing to learn, but when you really force them to do it, when you really force them to do the lightning talks and the Freaky Fridays and that stuff, then you find out they don't really want that. They just said they want to learn. So some people then figure out that this is not how they want to work. Okay, and before I come to my conclusion, I think we have a few minutes for questions. So are there any questions, remarks?
Yeah, so you said that you're kind of proponent of automating everything, right? So it might work in a product, like a product development, but when you're developing a project and you're doing it in iterations, this automation will cost you multiple times, because you're going to be changing some features that you implement, right?
Yes.
So you would still go for automation in those cases?
In many cases. I mean, sometimes you don't have the need yet to automate everything. So I would try to automate a lot of different kinds of tests. Like all the tests the developers do should be automated. This will save you so much time, because you will save time debugging, you will save time when changing things. But maybe you don't want to deploy multiple times per week or per day yet, so maybe you don't have to automate all your user-facing tests or all your security tests yet, or maybe you don't have to automate all of the deployment yet. But the point is, the more often you do something, when you do it by hand, the more often there will be failures, and each failure will cost you time and money. So I'm sure there is, for everything that you do by hand that you could automate, there is some break-even point where the automation is cheaper.
Yeah, but the problem is that if you automate everything, then the suite of automated tests is expanding.
Yeah, and it's really hard to write good tests. This is also something, when I do TDD trainings, it's easy to explain to people how to do TDD and to teach them to use or not use mock objects or stuff like that in 2 days. But you you can't really, or it's very hard to teach them that when you write bad tests, that this will bite you, and it will bite you much, much later. So yeah, even if you automate, you also need to architect and design your automation code, not only your production code. Yeah, sure.
Just to add to that about the testing, I think that's a really important point. I mean, I come from a development background ages ago, testing background,
Yes.
and kind of Agile stuff now. But if you've got testers manually running tests, I don't think they're testing. They're just checking stuff.
Yeah.
You know? And that's
Absolutely,
a really, really different thing to actually testing your process. If you've got people manually doing something, they should be exploratory testing, which are things that you don't necessarily want to automate, especially as you're developing features. You know, it's about all the weird and wonderful stuff that could happen. Completely agree with you. Anything that is a check, if you know what's going in, then you know what the answer is. That should be automated within bounds. You know, you don't want a 10-hour testing cycle.
Yeah, this is a good point.
And that's where I think where I've seen it work well is when you've got exploratory testers working with developers and business people to work out what scenarios are actually really important, what must work every time you release.
Yeah, so the idea here is that when you automate the testing, when you spend money and time to automate the testing, then you, in the long run, don't only save money because the tests run faster and more reliably, you also save money because your testers working on things that are more valuable than just checking that stuff didn't break. Yeah, that's a very good point. Thank you. Okay, to recap, Agile is about reducing risk and getting feedback. And yeah, to fight the anti-patterns or to do that, to reduce risk, get feedback, you must become excellent at creating software. Well-crafted code will ship faster than bad code. And to create well-crafted code, you need automation and Slack. And you also must make room for learning because creating well-crafted code is really, really hard. And I've been trying to learn this for the last 10 years or so. And I still know that I still have a lot to learn. And yeah, if you want to be truly agile, you must get really good in many different areas. So getting good at creating high-quality software is only one of them. But getting very good at creating high-quality software is a very important one of them. So can you do Scrum with only junior developers? Probably not in the long run, but you can start if you create a culture where learning and experimenting is resulted, then probably very quickly they will not be junior developers anymore. Okay, yeah, my name is David. I'm a freelancer, so I help my clients to get this right. I provide consulting, training, and other stuff. Never worked here in the UK, so if you want to hire me, we should do this as long as it's still possible, which is probably until 2020 or so. Yeah, you could follow me on Twitter, then you would get the discount code that I'm tweeting afterwards, or you can just take a picture of this slide. So if you order the ebook before, I think, next week and use this discount code, you will get it for 5 instead of 10 euros. There's also a paperback version, but I can't give you a discount code on a paperback because I'm barely making any money on the paperback anyway. So yeah, and thanks for being here. I think we almost finished on time. Thanks for being here. And if you want to talk to me about these things, I would love to talk about these things. I'm here until tomorrow evening, and I'm the one in the red shirt.